In this video, we're going to go over how to insert into a linked list. So here's the linked list again that we're dealing with. Here is the implementation in main. So this is not within a class, but just building it within main. So we already wrote build, we already wrote print, and now we're going to write insert. Insert is going to work by inserting the new node at this location using this value. So for example, if we wanted to insert this first one, we would basically put one here, put in the value, and we would link in it at the front. If we wanted to link it at location 1 for this one here, we would place it here at the first index and fill in the value and then rewire the linked list so that it would work. The thing about linked lists is that insert and remove are more efficient if you know where you would like to insert or remove. And I'm not talking about which one, but if you know what pointers you would like to insert at. If you don't know that, then you have to walk the list and find, where to place it, whether that is looking for a particular index or looking for a particular value. So there's lots of different ways to write insert. You could always insert at a particular location, like the front or the back, or some other pointer that you keep track of in the middle. The way that I'm going to show you this is how to insert at index I. So the idea here is that we are going to need to pass in a pointer to the front of the list, the location, and the value. And then what we're going to do is we're just going to walk the list and find the right index. So we're going to maintain the front of the list as the pointer list, and we're going to create a copy called node. That's the one we're going to move along. We're also going to have a previous pointer that we'll keep track of so that we can, rewire once we find it. Then all we're going to do is we're going to keep walking through the list by moving node by node until we find the index that we're looking for. So ind is going to count, how many that we're at, and then I is the one that we're looking for. Once we find it, then we just run all of this code here, which is going to be what actually inserts the new node. So this is an additional node, not replacing, so it has to be allocated. So when we get into this location, so let's do it for this example here. So at location 1, the first thing we're going to do is allocate space for the new node. Then we are going to place the value into the new node. We're going to need to be careful about this and make sure that we're not at the front, because the front is a special case. So if we're not on the first node, all we're going to do is link the previous node into this node, and then link this node's next into the next one that we create. I just explained that really bad. Let me explain it again. Okay, so we're going to go here. So let's say that we're already at index 1. That's what we're looking for, right? So we have found that location. So when we found that, node points here, previous points here, and we've just allocated space for a new node, and that is going to be add. We are going to fill in the value, which is high, and so now we need to link up prev, node, and add. So we're going to link up prev, which was previously pointing to node, and now it's going to point to add. We're going to link up add to node, so add's next is going to point to node, and then and then we're just going to update everything else as we move along the list. But for this particular one, as soon as we have inserted, we're going to break out, and then we're going to be kind of done. And then for this main implementation, we're going to just return the front of the list. So the list is the first node in the list, and now this will be rewired to now include all four of what we just inserted. So this is how you implement insert_at inside of main, so not within a class. So now let's move over and look at what it looks like in the LinkedList class. So the code is going to be really, really similar. I'm just going to point out some of the differences. So a big difference is the way you call it. You're going to call the constructor, and then you're going to call insert. You no longer have to pass in that node pointer, because remember, we keep track of the front of the list inside of the class. So instead of setting node to the parameter passed in, we're just going to set node equal to front. The rest of the code is pretty similar, but let's walk through it again to make sure that we understand it. So in this case, let's assume that you understand that you're walking through the list and you're moving prev and node along until you find the index that you're looking at. So in this case, let's practice this one here where it's at location 2. So 0, 1, 2. So you've found that node points to the second index. You have prev pointing to the one before it, and then you have allocated a new node, which add will point to here. We are now going to do a couple things. We're adding a new node and we're in a class, which we're keep tracking size. So anytime you call new, just like I showed you with the constructor, you're going to increment size. You're also going to update the value of that node that you just created, which is going to be B in this case. If you're not at the front, then you're just going to link up the prev to the one that you just created, add. And then down here, you're going to link up add. You're going to link up adds next to node, which is that one that used to be at the second index. And then you're going to break out of the loop because you've inserted and you're done. And in this case, the front of the list is here. So now the list is updated within the class, or within the instance of the class, and so that will be successfully added. The edge case here that I didn't go over in the last one is the front. So if you're trying to add something to the front, so at index 0, the only difference is that you just need to update the front instead of the previous nodes next. And so if you add to the front of the list, you still need to update its next, but you also have to update that the front points to the new node. So let's go over to Mima really quick, and you can just see what this looks like. So let's start with looking at the non-class implementation. So with the non-class implementation, let's insert at the front, make sure that that works. So to do that, we're going to do make build, and I need to comment out the class version. So the first print is going to be the original list, and the second print is going to be the list with Shannon inserted, because that's what I inserted here. So that works with 0. You want to test it with all sorts of inserts. You should just insert in a loop so you get lots of testing. I thought it'd be good to run valgrind on this one. Oh. So here you can see that I have definitely lost some memory, and that's because this does not have a destructor associated with it, right? So I actually have to, if I want to have a clean valgrind report on this, I am going to have to delete the memory that I allocated inside of main here. So if I try this again, but call one of my deletes, you know, I have 2 of them, and then I think I can just run it, right? Here you can see that that will free up all the memory. Let's do the same thing with the class. So when we run this with the class, we don't need to call delete because that destructor will be called, but let's check the insert function. So I'll insert something at 1 and then I'll insert something at 2. So I'll make build, make run, and I'll do numbers here so you can see what the difference is. So first it's printing out the original, then it's printing out an insert at 1, which is showing up here, and then it's printing out an insert at 2. A lot more to test, but that's the basic idea. So that is it with insert at on a linked list class.